So in this next lesson, we continue to focus on analyzing quantitative data. We talked about how to find measures of center, measures of spread. We talked about analyzing the shape of the distribution of quantitative data. And in this sense, talked about position within a distribution of quantitative data in terms of percentiles and z-scores. So now we're going to look at quantitative distributions and how they're affected if we were to add a constant amount to the data values or subtract. Take the data values and subtract by a constant amount. Multiply the data values by a constant amount, divide the data values by a constant amount, and see what kind of effect that has on the distribution that's created compared to the original. So looking at adding and subtracting, we've used this example before. These are the 12 salaries in thousands of dollars that we looked at before. And let's say we take this distribution and we're going to add $6,000 to every data value because every employee got a flat $6,000 raise. So here we see the original distribution data values, and we've already calculated measures of this. We found that the median was 34,500 and the range was 156,000. So the median is the measure of center. The range is the measure of spread or variability. So if we add 6 to each value, we get this quote-unquote new distribution. And if we were to calculate using this new distribution, the median, we would get a new median. There's 12 data values. So the median will be the average, two numbers in the middle, which works out to 40,000. If you calculate the range, well, the original range, if we took the maximum data value minus the one, we got 156. With the new distribution, if you take 191, it's got 35. Once again, get 156,000. So we can see that if we add a constant amount to a distribution of data values, we would also add that same amount to the original median to get the new median. For the range or the measure of spread that we're using here, the original range was 156,000, but when we added 6,000 to each data value, the range stayed at 156,000. So what that means is that if we were to add or subtract constant amount to a distribution, the measures of center, like the mean and median, would would increase by that constant amount or decrease by that constant amount if we were subtracting. Okay, so that's measures of center. However, the measures of variability, and by this range and standard deviation and IQR, that remains the same. That doesn't change. Okay. The shape, I know I listed it first, but I'm going to talk about it last, actually doesn't change as well. Because if you think about it, if we take a distribution and then we shift it to the right, the shape is still going to retain, or is still going to be the same, regardless if we added a constant amount by shifting to the right or subtracted a constant amount by shifting to the left. So the shape remains the same. So that's what happens when we add or subtract to a distribution. What happens if we multiply or divide by some constant? on a distribution. So again, we're going to use the same set of numbers, 12 salaries. And this time, every employee is going to get a 10% raise. And what that means mathematically is we are going to take your original salaries and multiply by 1.10. So we're multiplying by a constant. And once again, we're given the median of the original, the range of the original, and we want to see what happens to the median of the new and the range of the new. So here's our new distribution. If we were to calculate the new median by taking the average of the two numbers in the middle, we would get a new median $37,950, which is actually the original median, 34,500, times the fact that we multiply. So we can see that the median, if we multiplied all the data values by 1.10, we would also multiply the median by 1.10. For the new range, what we took as a distribution, we took the max value minus the min value, we would get a new range of 171,600, which is actually the original range, 156,000 times 1.10. So we can see in this case, when we multiplied and divided by a constant, well, when we multiplied by a constant in this specific case, the range was also multiplied. So the range changed the same way that the original data values changed. So to summarize here, when we have some data, or when we have a distribution and we multiply or divide by a constant amount, the measures of center, such as the median or the mean, will also be multiplied by that constant amount. As well, the measures of spread or variability, such as the range, standard deviation, R, would also multiply or divided by that constant amount. The shape, what would happen to the shape of the distribution? Well, if we have a distribution of data values that takes that shape, if we multiply by a constant amount, it's just going to make the shape bigger, it's still the same shape. So once again, the shape. So we can see what happens when we perform all four operations on a data distribution, adding, subtracting, multiplying, dividing by some constant amount. So how can we use that in certain situations? Well, let's take this next example. Well, we can apply our understanding to answer questions much more efficiently. So here we have a person taking an Uber ride in New York City. Initial fee is $2.55. The additional charge is $1.75 per mile. And in equation form, that translates to cost of the ride equals 2.55 plus 1.75 times the miles. So New York City residents reports the number of miles for his first 25 rides, and he finds that the mean distance of his rides is 5.6 miles, and the standard deviation is 1.2 miles. So what we want to do is we want to find the mean cost of the 20 trips. Well, to do it the long way, we would have to find out, okay, how long was each of the 25-mile rides, get that new distribution and calculate the new mean. However, we can use the formula to calculate it directly. And what we would do is we would say cost is equal to the initial fee plus the amount charged per mile times the mean number of miles. Because remember, we saw that the measures of center, if we add some constant amount, then the measures of center will change the same way. If we multiply by some constant, the measure of center will change the same way. So we have to include the multiplying and adding to get the new mean, or sorry, to get the mean cost of $12.35 based on the mean number of miles of those 25 trips. For the standard deviation, we would not include the plus 2.55 in the formula, because remember we saw on the previous page that adding or subtracting the constant amount doesn't change, has no effect on the standard deviation, so we don't include it in our formula. However, multiplying or dividing does have an effect, so we have to include that in our formula. So to get the standard deviation, we would multiply 1.75 by 1.2, and we'd get $2.10. How do we interpret that? We would say that cost the trips by this risk. When we standard deviations, we use the phrase typically varies from the mean. Typically varies from the mean. By the standard deviation amount, units, $2.10. So this is what happens when we transform data and how we can use it to answer certain statistical questions more efficiently.